today is about a proposal for a new benchmark. We call it Web3-Bench. And we're trying to create a benchmark that's suitable for HTAP. All right, so do some background about what's performance benchmarking overall and why we need that, and then where some of the examples where benchmarking is being proposed, and why we need specifically benchmarking for HTAP. What are the current solutions and the gaps in these current solutions, and then what we are trying to propose here to cover these gaps. Okay, and then we go in some level of details on what is the proposed benchmark, what is the data model, workload, and how we did evaluate the benchmark on TiDB. Okay, welcome guys. I guess maybe it was hard to find the room? Yeah. Oh, okay. All right. So we just started. You didn't miss much. Okay. All right. So this is the agenda about the Web3 bench. So benchmarking database management system is something not new, right? It's as old as DBMS itself. And there is so much work in this area, and there is so much research in this area. And the goal is trying to measure the performance of database management systems. And usually these benchmarks are composed of some data model trying to represent a real-life use case. And along with that, some tool that produce the data. And then a bunch of queries that will be executed on this data model. And then some metrics. So you want to measure metrics. You want to measure latency. You want to measure throughput. So you could compare execution of the benchmark on two different systems, right? That makes sense, right? Okay. So that's benchmarks in general. And requirements, which is common sense, right? You have to have something reproducible. You cannot run the benchmark on system A and get some results and run it on system A without any change and get different results. It has to be reproducible, right? Something reliable. And something you could measure, right? Otherwise, if you cannot measure it, then what's the point? How can you tell if system A performed good or below expectations on the system? And it has to be non-trivial, right? It has to be something substantial and for the data set itself and the workload. If it is something very simple, then it's not going to be used to differentiate different systems. And we would like to have it also as representing real-life use cases, because otherwise you're running a benchmark that's not realistic, right? People cannot make use of that. So why is it useful? A couple of reasons. Internally, for DBMS solution, people use it internally for performance regression. You have a release. You could have daily performance regressions, release-based performance regression. And sometimes engineers, they build prototypes. They want to check. They want to get an early on if they're causing performance improvement, performance regression on their prototype. They can use the benchmark, right? Some companies like Teradata, when I work for Teradata, some of those benchmarks can be used to measure the release value. So you could say this release is going to give 5% overall improvement, and then this can be useful to actually price the product itself. Externally, for marketing, people use a benchmark for marketing, say, hey, our product runs well on this benchmark. Or some customers, especially in the old days, they used to use benchmarks for vendor selection. If you are familiar with the TPC benchmarks, that was very common in the past to use it for vendor selection. Especially it was in India, in China, and different Latin American countries also, they used to do that. I don't think that's very common these days, but in the past. Okay, so these are some of the ones I know. There are so many venues for benchmarking, but the one I'm most familiar with is this TPC. And this is a council that produced many benchmarks for OLTP, for analytical processing, big data, and I was the primary author of this TPXBB, and that's why I mention it here. And a lot more benchmarks at this. And actually, they have an annual conference as well. It usually goes with VLDB. And there is this bench council that actually we're working with recently with PingCAP. It's called benchcouncil.org. Okay, so these are some of the venues. In terms of conferences, this TPC-TC, this annual conference, ICBE for performance engineering. There is DB test. Usually it goes with SIGMOD, if you're familiar with SIGMOD. T-Bench, and these famous common research academic conferences, VLDB, SIGMOD, ICDE, right? And we sometimes we try to publish at those conferences. Okay, so we're moving to HTAP benchmarking. So we talked about benchmarking in general, right? And talked about some of the motivation, what goes on there. So the HTAP itself is a growing area. Obviously, it's a growing area. We need to also work on good benchmarks for this growing area as well. So people have done already work on HTAP, specifically for HTAP benchmarking. And there are a few solutions. I'm going to talk about them before I talk our benchmark. Okay, so some of the early attempts at the HTAP benchmarking was just gluing the TP and the AP, right? Because HTAP, the claim, it does transactions, it does analytics, so people have just combined TPCC and TPCH. If you are familiar with those, TPCC is used for transaction processing. Very ancient benchmark, has been proposed for a long time. It still goes on. And TPCH for these analytics. Okay, so there are a bunch of, there are at least 2 benchmarks that try to do this, just combine those. So they don't really represent the real life case of HTAP, right? That's not what HTAP is about. There are no standards yet. I've read about TPC considering one of these, one from HammerDB. We're going to be trying to push our benchmark for a standard if things goes well. And there are 2 recent benchmarks for HTAP beyond the gluing. So the gluing was the simple thing, and there is some recent work. Actually, they're both from top universities, more for research projects. The first one is Hattrick, University of Wisconsin-Madison. They actually ran it on TiDB, I think last year. And there is this OLXP bench from Chinese Academy of Science. And actually, they try to address the initial solutions, which are limited. So they have done a better job of integrating the TP and the AP. They tried to measure the freshness of data as a metric. But we still think there are quite a bit of gaps. I mean, looking at our workload, which really a good representation of HTAP in general, we're talking about online serving. So online serving is not covered by those. And when I talk about online serving, I talk about the workloads between the T and the A. So this is what I call online serving. It's things that needs to be executed under 10 seconds. So that's one issue with these 2 recent benchmarks. If you like, maybe we can close the door. Yeah. Thanks. And also, these benchmarks also kind of recycled the old data models from TPC. This whole TPC was based on this retail model, products and sales, and things like that. So that's another disadvantage in my opinion. And also, they have not run their benchmark, their workload. They run it on low queries per second. So our own experience, which really a representation of HTAP, you have high QPS, you have a lot of this online serving, you have a lot of point queries, and you have few AP queries also. All right, so given these gaps, we thought we could come up with a new proposal. We call it Web3-Bench, trying to address the previous benchmarks. And the reason we chose Web3 is really very common for us and for everybody, and it's really a good example of HTAP, right? So that's why we thought Web3 will be a good use case. And also, we kind of go beyond the retail model used in TPC. So that will be a fresh data model with a good use case, and it supports the online serving as well. And the way we have designed this is that we said there is the T queries for transaction processing, and there is the O queries, which is for online processing, and there is the A for analytics. We have divided like this. So you guys feel free to ask questions if you have any questions. Okay, so that's maybe the high-level motivation. So how did we come up with the data model? That's the first thing you do with your benchmark design. So we looked at Ethereum. Ethereum is really a good Web3 example, Web3 data model. And we adopted their data model. We simplified it for our own benchmark. It's an excellent Web3 use case. And you know, if you know Ethereum, it's second to Bitcoin. So just like Bitcoin. But the difference is that they have more data available. So they have public data available. They are not really a relational model, but Google have created a relational model out of Ethereum. So that's the one we have used. So Google BigQuery, they have 7 tables data model for Ethereum, and we use that. We simplified it a bit. So this is the way we have simplified it to 4 tables. If you're familiar with cryptocurrency, these are the core 4 tables: transactions, blocks, token transfers, and contracts. Okay, so, and I think in the original Ethereum being relational by BigQuery, there are 7 tables. So that's our data model here. This shows just the simple primary key PK FK relationship between these tables. But they have a bunch of more columns than what you see here. Okay, and then, okay, before I go on, this project was in collaboration with the Chinese Academy of Science. So PingCAP, I worked with the 2 graduate students over there, and we basically did the design and the scope, and they did the implementation for us. So they implemented the benchmark for us. So the data generator, this is a brand new implementation by us. And basically, we have used the Ethereum sample data. We got a sample data from Ethereum. We extracted some data demographics from there so that we can have a real life, scenario here. And that metadata, along with what's called a scale factor, and a good benchmark should have a scale factor, so such that you could run it on a small data set and you can, scale it as much as you can. This is what typically in TPC, if you're familiar with the TPC benchmarks. Okay, so the data generator will you say what size of data you want, and give it some data demographics like the relationship between the tables, frequencies, just some basic information, like for how many foreign key values for one primary key values, which you can also, we call it in database, we call it frequencies, right? How many transactions per block, for example. So that information we use, we produce some synthetic data for Web3, and we save that, okay? So that's basically what I was talking about in the figure. And the scale factor 1, that's the smallest scale factor, is 5 gigabytes of data. Okay, so you could go as small as 5 gigabytes if you want to run this benchmark. So workload, the queries, and that's maybe a major contribution we have, is, so the workload will have reads and writes, right? So that's something you have to do. And we're doing some intelligent guessing here, right? We said 80% reads and 20% writes based on talking to some people, some customers, that majority of the workload are reads, but there is quite a bit, big portion of that are writes. And the queries actually, so you could think of the T and the A as a given, that we have to have transaction queries and A transaction, but we're adding this O, this online. So I've looked at some people talk about the user interaction, and they define the user interaction into 3 buckets. Under 1 second, under 0.1 second, and under 1 second, and under 10 seconds. So the 10 seconds is what you could call it keep user attention, 1 second user flow of thought, and the 0.1 is the instantaneous. So we defined these different classes, and we built the workload based on those definitions. And we looked at some of our customer cases that they shared to us, and we actually, we were inspired by some of the use cases we have seen from our own Web3 users. Nothing from their data or anything, just from the high-level architecture here. Okay. For the writes, for the 20% writes, also we have broken that into 80% answers, to 15% updates, 5%, also some intelligent guessing here. And we built this workload driver. And then I'm not showing here some of the details, but later on when we have this as open source, you can see that for those interested. So we have defined some SQL queries and some DML for these buckets. And then we implemented the workload driver that submits the whole workload concurrently. The T queries, they are submitted the most frequent, then the O, then the A, right? Which kind of represents the real life cases. Point queries are much more common than online serving, and complex queries, they are less common. And we are mandating response time for the T and the O. Since we are saying these instantaneous and these are online serving, so other benchmarks, they just measure overall throughput, and that's it. But we were also, for a successful execution of the benchmark, you have to meet the time limits for the T and the O, right? And we're measuring also the metric like similar to other benchmarks, where you compute the average response time, the throughput, and what have you. Right? We run this on TiDB for verification. We're not in the stage of comparing TiDB on other things. That's not the objective here. Objective is to propose a benchmark. So we run it on TiDB because we know TiDB well, just to see if this benchmark is feasible or not. We run it on a scale factor of 300. And scale factor 1 is 5 gigs, so you could do the math. The benchmark runs successfully. We have to do some tweaking on some of the queries to meet the requirements. And yeah, basically it passed. The T and the O requests, they passed the time requirements. They run within these latency requirements. The overall metric is not relevant here, right? Because we're not trying to measure performance. And another interesting thing about Web3Bench is that we have built another product called Index Advisor. I think Ed talked about this in the morning. So we have tried our Index Advisor and the Web3Bench, right? And we got significant performance improvements, which actually validates both. So we could say that Index Advisor, this was a good success story. And also Web3Bench itself was a good use case that actually the Index Advisor have actually provided quite a bit of performance improvement by these additional indices. So there was like about 85% performance improvement. And I guess we're going to release both the Index Advisor and the Web3Bench soon. So yeah, in summary, we definitely need some benchmarks for HTAP. We need to measure HTAP. Current solutions have some gaps. They either glue the AP and the TP, or they don't address online serving. So online serving is a key motivation here in this benchmark. And we designed it, we implemented it, we ran it on TiDB, and was successful. We're looking for more adoption by other HTAP solutions. So we're going to be sharing this with other HTAP companies, and we're going to have it on GitHub soon. Thank you, thank you. All right.